In this chapter, we're going to be dealing with integer exponents, and let us do some. Let us refresh our memory on basic properties of exponents, and in particular integer exponents. So let us assume you have 3 that is raised to the power of 5, and again, let us be reminded that this is essentially multiplying 3 by itself. 5 times 1, 2, 3, 4, 5, and that ends up in 243. So this is the first quick example of an integer exponent. One point of caution, which is a common mistake, is say the case of -2 in a parenthesis that is raised to the power of 4. That is not equal to -2 raised to the 4, and the reason is if we multiply -2 4 times by itself, so if you count the negative and negative becomes positive, negative and negative becomes positive, so your final result will be a plus 2 times to the 4, which is of course plus 16. A couple of points here that you should always pay attention to. By definition, any number a, as long as it is not equal to 0, non-zero number, then you're always going to get an a raised to the power of 0 equal to 1. By the same extension, by the same token, if you have a non-zero number a that is raised to the power of -1, here's a negative integer, then this is going to be 1 minus a raised to the power of 1, which is of course simply 1 over a. And in that, if you have 5 raised to the power of -2, that will yield naturally 1 over 5 raised to the power of 2, and this is 1 over 5 times 5, and this is 1 over 25. Now I'd like to, let's erase this part. I think we got this, and you can always rewind the video and watch it again if necessary, of course. One other important property is when we have a base, in other words, to say 5 raised to the power of 2 times 5 raised to the power of -3. What happens in this particular case? You're going to have, as long as you have the same base, in other words, 5 and 5, you can always write 5 raised to the power of 2 plus -3. In other words, we're adding the 2 exponents, and this ends up in 5 to the -1 or 1 over 5. Now, in other words, that said, we can not claim that, say, 5 raised to the power of 3 times 6 raised to the power of 4, that is not equal, of course, to 5 times 6 raised to the power of 3 plus 4. That is not the case. No big time, because as we said, not the same base. Very important properties. Now, in the case where you have, let me get this part of the board cleaned up. Here's another example where you can have exponents and do operations between exponents. That will be highlighted by this example where you have 5, base 5, raised to the power of 3, and the whole expression is then raised to the power of, say, 2. So what do you do then, right? In this particular case, you're going to have 5, and the two exponents will be multiplied together. So that is 5 raised to the power of 3 times 2, that is 5 to the power of 6, and you can get this from a calculator. Again, by the same token, if you have, say, a fraction 5 over 3, and this expression is all raised to the power of -1, that is going to essentially yield, the exponent will go to both parts of the fraction. You have to raise both the integers to the power of -1, that is 5, -1, 3, -1, and this is essentially 1 over 5, and this is 1 over 3, that's a complex fraction, and then you get 3/5. Okay, that is also another very important property. And in the end of each chapter, I'm going to give you a quick homework where you can practice, and I will be also posting the solution along with the lecture.